to a much lesser extent due to the consistent application of engineering principles to the software development process. Computing resources have become more widely available, and standardized methodologies for software development allow for large, complex solutions that scale. The solution to the software crisis involves transforming unorganized coding efforts into an established engineering discipline. The mid-1980s also saw a rise in the growth of computer-aided software engineering, or CASE, which also helped to relieve the software crisis. CASE tools can be divided into 6 categories: business analysis and modeling, development tools such as debugging environments, verification and validation tools, configuration management, metrics and measurement, and project management. Now, the term software engineer is often used interchangeably with software developer, but there are subtle differences. Software engineers are also developers, but the term software developer is usually deemed narrower in scope than that of a software engineer. A software engineer's knowledge is usually broader. Software engineers take a systematic big picture approach in their thinking to software development, whereas developers may have more creative approaches. And both software engineers and software developers have specialized knowledge, but software engineers use that knowledge to build entire systems, whereas software developers use their knowledge to write code to implement specific functionality within a system. Software engineers are often employed on larger scale projects, and they are focused on the broad structure rather than solving an immediate problem. Software engineers are tasked with designing, building, and maintaining software systems. Their responsibilities include writing and testing code and consulting with stakeholders such as clients, third-party software vendors, security specialists, and other team members. The adoption of a measured scientific approach to software development has influenced the way software is created and designed. Today, the development process is typically guided by the Software Development Lifecycle, or SDLC. The SDLC identifies the steps needed to develop high-quality software. Later in this module, we will discuss the SDLC, the traits of high-quality software, and roles common in the field of software engineering. In this video, you learned that software engineering is the systematic approach to design and development of software. Responsibilities of a software engineer include designing, building, and maintaining software systems, writing and testing code, and consulting with stakeholders, third-party vendors, security specialists, and other team members. And finally, software engineers build systems while software developers implement specific functionalities. Welcome to Insider's Viewpoints. What is software engineering? In this video, we will hear from experts discussing software engineering.
I think software engineering is the process of using programming languages and engineering principles to build products. These products could look like web apps, mobile apps, desktop apps, operating systems, or even networking systems. It is a skill that's integral to the success of our modern society because without technology, we couldn't get a lot of things done today. Within software engineering, it's a very broad term, and so within software